You are all familiar with the estimate. If you ever took the car to mechanic, right, to change a license plate bulb, for instance, mechanic says, well, it's anywhere between $5 and $75,000. I'm 100% sure it's somewhere in there, right? Or if you need to change anything with the contractor in a house, right? Pretty much the same deal. Pretty much always better off buying a new house than fixing a pipe. Which is, yeah, the trade, right? I know. You go to school to be a middle class, at best, right? If you want to be rich, trade school. So, what do we do with this information? So we're going to take a sample, and we are going to make an educated guess about population, and we're going to be certain to some extent of how good our prediction is. So first we write the definition for point estimate. A point estimate of a parameter is the value of a statistic used to estimate the parameter. So a point estimate of a parameter is the value of a statistic used to estimate a parameter. So if it's a mean of population, the point estimate would be sample mean, because that's the best you can do, right? So example, for population mean mu, point estimate is sample mean x bar. I'm going to spell it out. Sample mean x bar. So I don't know what the average height of all either female or male are, but what I can do is I can get the sample, and we learned in a previous lecture, the larger the sample, the better. I can get the sample, unbiased sample, get those heights, and the best estimate of the population mean would be the sample mean that I obtained. And then we want to come up with some confidence intervals. Confidence interval estimate. Where we say, more definition now. Confidence interval, we denote that with a CI, is an interval of numbers, so interval of numbers obtained from a point estimate of a parameter. Confidence level. the confidence we have that the parameter lies in the confidence interval. And then confidence interval estimate is just these two things combined, so I put that as a title. So confidence interval is these two. There we go. Now let's talk about this confidence interval. And remember how I mentioned mechanic? And you go to mechanic to change the license plate bulb, which you can order online and replace. In some cases, it's a quick switch. In some cases, you have to unscrew 2 screws and put the bulb in. This thing is at most $5 online, right? $3.99, you can find it. So it's something that is very cheap. Now, if you take your car to the dealership for that to be changed, because you will get a ticket of $50 if you have that broken as failure to maintain bulbs. Oh yes, of course. 2008 January. So, do you need the last name? So, the estimate at the mechanic shop was between $5 and $72,000, right? That's what I said. Why? Because I'm 100% certain that, the price of changing that light bulb will be between these two if you, bring your car in. Now, I am 99% confident that changing the light bulb at the dealership will be between $5 and $100. I am 98% certain that it's going to be between $5 and $90. You see that? So as I am tightening the range, right, the price range, I am less certain, right, that the price will actually be in between those two numbers. So it's a game of give and take. Really wide range will have a good confidence interval, but then the really wide range is kind of useless, right? Because if you bring in a car and the mechanic says, yeah, to change this bulb is going to be anywhere between $5 and $1,000, no, right? So you want to have an estimate, the range. Now these things are very important for, let's say, a house or something where, they don't know what they're going to find once they open up the wall. You could have rotted studs, you can have mold, you can have, right? So all of these things would add to just fixing a water leak. So they give the range, they give the estimate, but then that could be wrong. So the wider the range of estimate they give, they have more confidence that the price that actually is the price will be between those two numbers. If they gave a very narrow estimate, then the uncertainty is large because it's easy to go over budget for these types of things, let's say fixing a pipe. So I hope that makes sense just because you are alive and dealt with something in your life at one point in time. So confidence interval is going to be a number, and we actually get to compute these things in the next section. We'll see how we use z-scores to compute number to you subtract and add to the mean to create the confidence interval. It's not going to be something arbitrary. It's going to be something that to compute. But right now, we're just going to give those numbers. So sample mean x bar equals 5, right? And then we're going to get this number, which we call margin of error, to be, let's say, 2.1. So your confidence interval in this case would be 5 minus 2.1 to 5 plus 2.1, and we put that in parentheses because it's an interval from A to B, interval of time from 1 p.m. to 3 p.m. That's interval of 2 hours, right? So both of these are x values. For the total of 2.9 to 7.1. Now, I did not give any context of this. It's just, a range of some kind. But let's go and take a look at the actual problem. And by the way, the lecture is over. The theory is over. We just need to take a look at the examples of what they have. We do calculate, let me just see. All right, so margin of error So for margin of error, we can say construct 95% confidence interval for the mean price mu. And margin of error will be added and subtracted to the x bar to provide the interval in which the mu population mean is. So you have x bar plus minus margin of error. This is just understanding what this means, because the next section is when we calculate. You will have the z-score and deviations and all these kind of things to compute. Right now we're understanding the words and concepts, no calculations. So x bar is your sample mean, and then margin of error, which is added and subtracted to this to create the interval, which is x bar minus margin of error e and x bar plus margin of error e. So now we can say, because I use 95%, right, I can say I am 95% confident that population mean mu is in x bar minus e, x bar plus e. So your answer starting right next section, will be something like that. We are going to use 95% confidence interval to figure out the z-scores, because 95% confidence under the bell-shaped curve, that's going to translate into those areas translate into z's, and z's will be used to compute these errors. You will have the sample mean, you add and subtract, and you create the confidence interval. And then you will be 98% confident, 95% confident, 90% confident that the population mean mu lies between those two numbers. You don't know where, but somewhere in between those two numbers that you computed. And that is going to be reserved for the next class. And we'll go from there. So I think we have 4 or 5 sections to work on in chapter 8. No, I lied. 3 sections to work. So another 2 sections, and then we have chapter 9 to talk about hypothesis testing, which is where you can finally apply this to science and so on. So I'll see you all next class, and we'll do some calculations. Bring z-scores so you can look at those charts.